planting these two trees. So it's kind of similar to what we were looking at before. Only thing, this time, one tree starts at 50 inches and it's growing 2 inches per month. This is a rate, and so this is going to be written as 2 times M. What we're trying to figure out is how many months. That's what we don't know. So that is our variable. Equals 59 is where the other tree started, and it's growing at 1 inch per month. I think this is a pretty easy one to solve. I don't know if you want me to solve this one or if you want me to look at 21 or 22. But I'm not going to be looking at solving all of them, okay? So you would have subtracted 1m from both sides and then subtracted your 50 and solved that equation for the number of months, okay? As you take a look at number 20, first thing we know is that these two people, they've read, we're looking at when will they be on the same page. So we're trying to see when what Li Wei has read is going to be equal to what Colleen has read, right? What do I know, Daniel, about how much Li Wei has read?
Li Wei has read 90.
90. Plus how much is she reading each hour?
30 pages now.
Plus 30, and maybe we go with P for pages, right? We're trying to see when they're going to be in how many, when will they be on the same page? So in this case, we're kind of looking at maybe how many hours we're looking at. So I don't know if you want to use P or if you want to use H, doesn't matter. Equaling, what do we know about Colleen if we are reading that, Courtney? She read what? 126. Should we have the variable with 126, do you think? No, because we're looking at plus what, Courtney? How much is she reading an hour? Plus she's reading 24. And so maybe an H sounds better than P, but once you pick your variable, it doesn't matter. You just want to use it the same on both. Should I solve this one? You want to look at this one? So if we are doing this, I want to get rid of my smallest variable first. So I'm going to subtract 24p from both sides. I now am left with 90 plus 6p is equal to 126. Next step would be to do what? Subtract 90 on both sides of my equal sign. And I now have 6p is going to be equal. 126 minus 90, what did you end up with when you did that subtraction? 36. So in how many hours are they going to be the same? Dividing both sides by 6. Our variable was equal to 6, and it said, if they read this, when will they be on the same page? In 6 hours. So you want to make sure you answer the question. In 6 hours, they will be on the same page. So making sure whatever the question was asking you, just like in science and in English, you're finishing that with in 6 hours, they will be on the same page. So 21 is just a little different. 21 says the cost of roses per dozen is $15, and you want to purchase 9 dozen and 6 individual for a centerpiece. It says the price for 9 dozen and 6 individuals can also be found by roses. You could also purchase 51 for the same price. And the question is, how much is each rose? So first thing we need to know, how much is one rose? We need to know what our R equals. And then it says, how much are you going to spend on your centerpiece? So we need 2 answers, okay? When you look at that. How much does the centerpiece cost? Okay. So what we know about the centerpiece was that it was 9 dozen plus 6 individuals. Each dozen cost $15. So 15 times 9, because we had 9 dozen, plus 6 roses are. And that was exact same price as if I buy 51 roses. So I'm going to multiply here, subtract 6R from both sides, and then divide by that number that I have as my coefficient of R. that will give me, when I solve for r, that will tell me how much each rows cost. And then to find the centerpiece, that's where you're taking the 15 times 9 plus 6 times the cost of your rows. So whatever your rows cost, and then we'll put that in to get that answer. Okay. If I'm looking at number 22, and I'm not going to finish solving that one because you're not handing this page in today, so if you didn't finish this, you can finish these a little later. Here, one of the first things we want to do is add our like terms on this side of our equal sign. So we have 5m plus 18. If I take 15m and I subtract minus 4m, Braden, what am I going to end up with? 11m minus 24. Sage, I now want to get all the variables on one side, and I want to subtract my smallest variable. Which one?
5.
So I'm going to subtract 5m on both sides. When I subtract 5m, at this point I have some people doing their variables too. The only thing is that I sometimes have people make a mistake which number they're subtracting. So my hint is keep this as 18 equals, in this case we're going to have 6m minus 24. Because now if I'm solving this, Chloe, what do I need to do?
Oh, we need to.
18 equals 6m minus. So I have 18 equals 6m minus 24.
Oh, you said.
Do what? So if I take 24, a negative 24 and minus 24, that'll give me a negative 48. That doesn't help me out. What could I do to get rid of a minus 20? Add 24. So we want to add 24 on both sides. So we're taking 18 and we're adding that 24 to 18. So that I'm going to have 6m, and I'm kind of running out of room. So I had 18 plus 24. Which when I add those together, would you have, Haley? 18 and 24 if we add those. And we're going to divide both sides by 6 to get our m equals 7. Now, what has been the case in all of our problems up to this point is that you have had one answer for all of our problems. Today, we're going to see where that is not always the case. It is not going to be that we have more than one. Well, it could be that we have more than one answer. So I'm going to have you turn right now and put your workbook aside, and let's look at your notes. And as you're looking at your notes, the standards that we're looking at is I can solve linear equations involving rational numbers that justify the solution path. The justify, that's the showing your work that you're doing. And I can determine the number of solutions. So up to this point, we've only had one solution. So Thane and Wyatt, I need your attention up this way. So up to this point, we've only had our one solution. All the equations so far have had one thing in common. They all have exactly one solution. If you think about this, I want you to think about any equation that will not have exactly one solution. Anyone have any ideas on an equation that could not have one solution? So I want you to think about that and just, if you think about an inequality, right? When I say x plus 2 is greater than 7, if you were solving this, you'd subtract 2 from both sides, and x would be greater than 5. And that would mean, what are my solutions? X could be 6, it could be 7, it could be 8, right? It could be 7.236, right? It could be, there's actually infinitely many numbers. And when we solve equations, there is also two different possibilities that we're going to look at today. One is that we could have, when we solve just an equation, right? So this is an inequality because you have a greater than. But when we have an equation, you could have no solution. We're going to look at that today. When there is no answers that make it true, okay? The other thing we're going to look at today as we watch these videos is we are also going to look at where it could be infinitely many solutions. That means every number that I pick will be an answer. So infinitely many means that every number that I choose is a solution. So every number that I choose is a solution. Please make sure you write that down. Every number that I choose is a solution to the problem. Whereas the first one, there is nothing that I can choose that's going to make it true. Okay? So those are going to be my two possibilities that I'm going to be looking at. Okay? Infinitely many and no. So, on the top of the next page, it says, what numbers for x make this true? What do I need to do to get rid of the x on this side if I'm looking at that, Layla? Subtract x. Subtract x. So let's write our problem down over here, and let's write down x plus 1. So let's write out the exact same problem, equals x plus 2. If we subtract an x on both sides, it comes out that x minus x is how much, Sophie? 0. So this is 0 plus 1 equals over on this side 0 plus 2. Have you ever known 1 to equal 2? This is a false statement. Okay? So as we watch this video, this is a false statement. And when we have a false statement, in this video they're going to talk about what number x could be. So we're going to watch this video. And as you watch the video, they want you to summarize. So as you're watching it, you don't have to write down everything in the video, but you kind of want to look at that and go, oh, this is what they mean that they are looking at. Okay? So I'm going to put up the video.
Problem has no solution. Well, to figure out what that means, let's look at a couple examples of problems that have no solution. Let's look at x plus 4 equals x plus 2. This looks kind of like a normal equation. But look at what happens when we try to solve for x. Let's move this x to the right-hand side of our equation. To do that, we subtract x from both sides. And then on the left, these x's cancel out, and we're left with 4. On the right, these x's cancel out, and we're left with 2. All of a sudden, we're left with two numbers that do not equal each other. 4 does not equal 2. This is a false statement. If you get a problem like this, where the variables cancel out, and you're left with a false statement, you have a problem that has no solution. In this case, no value for x will ever give you a true statement. To see that, let's look at another example. 10 plus 6x equals 15 plus 6x. Again, this looks kind of like a normal equation, but this is in fact a problem that has no solution. No value that you plug in for x will ever make the statement true. To see that, let's pick a couple values for x and see what happens. So let's pick x to be 2. So we get 10 plus 6 times 2, and we want to know if that equals 15 plus 6 times 2. Well, simplifying, we get 10 plus 12, and does that equal 15 plus 12? 10 plus 12 is 22, and 15 plus 12 is 27. 22 does not equal 27. We get a false statement. So that means our value for x, 2, does not work. But what if we pick a different value for x? X equals 6. Let's see what happens then. We get 10 plus 6 times 6, and does that equal 15 plus 6 times 6? Well, we have 10 plus 36. Does that equal 15 plus 36? 10 plus 36 is 46, and 15 plus 36 is 51. 46 does not equal 51. Another false statement. So, this problem has no solution. No matter what value we pick for x, whether it be 2, 6, 105, we will never get a true statement. Now to see this, let's try to solve this equation for x and see what happens. Let's take this 6x
So exactly
and move it
like
over
we've
to
been
the right-hand
doing.
side. So we subtract 6x from both sides. On the left, these 6x's cancel out and we're left with 10. On the right, these 6x's cancel out and we're left with 15. Uh-oh, another false statement. 10 does not equal 15. So, we get a false statement. This problem has no solution. Now that we've seen a couple examples, let's look at our definition. When a
So this is
problem
what we
has
want
no
to put in
solution,
our notes
it
as you're
means that
looking.
no matter what value you pick for the variable, you will always get a false statement. In other words, there is no value you can plug in for the variable that will make this statement true. So, if you get a problem where the variables cancel out and you end up getting a false statement, that means that there's no value you can pick for that variable to make the problem true. In other words, you have a problem with no solution.
She writes faster than I can finish.
All right. So let's look at what she was saying. The video says that as we solve up here, whenever you solve and you get a false statement, right? Anytime it's false, like we got up here, that means your answer is going to be no solution that you're going to write down. Okay? So if we are looking at that, anytime you solve and get a false statement, because what we know up here is that 1 does not equal 2. That was a false statement. So the video was saying, if you get a false statement, it means our answer will be no solution. So today in some of the problems, you're going to get an answer. Like it's going to come out x equals 4. You leave it x equals 4. You're going to get x equals negative 3/5. You're going to leave that as an answer. But if you get a problem and you're solving it and it comes out to be a false statement, the variable's canceled, you're going to write no solution. Okay? So let's look at this problem. Top of that next page, problem 2. It says if we are going to work this out, so if I'm going to use a distributive property, right, and I'm going to solve this, I have 2 times x plus 3. What am I going to get when I use the distributive property? 2x plus 6. And that's equal on the other side, if I look at what they have written, as 6 plus 2x. So I'm looking at that problem, and Carmen, if I want to eliminate my variables, what are you going to do to eliminate the variable? Subtract what? Subtract 2x. And I subtract 2x on both sides, and this time when I do that, this 2x is canceled, so that's really 0 plus 6, right? Equals on this side, 6 plus 0. You don't have to write the 0, you could just put 6 equals 6. Well, if 6 equals 6, what does that mean for our solution? So, in this one, we are going to look at when we get true statements, okay? So when you get a true statement, think about, okay? So we're going to write it in the same way. What are we going to write for our answer when we have a true statement as we look at that?
What is an identity equation? Well, to figure out what an identity equation is, let's start by looking at a few examples. 27 equals 27. Well, that's a true statement. This is an example of an identity equation. When the left-hand side always equals the right-hand side of our equation, we have an identity equation. Now, they do get a little bit harder than 27 equals 27. So let's look at another. 15 plus 12 equals 15 plus 12. A little harder, but we can still see the left-hand side is identical to the right-hand side of our equation. This will always be a true statement. And if we can't see that, we can simplify both the left and right-hand sides, and we end up getting 27 equals 27, the first identity equation we looked at. Now, let's add some more operations to it. Let's have 15 plus 2 times 6 equals 15 plus 12. This is another identity equation. But now, the left-hand side does not look identical to the right-hand side. But if we simplify, they do end up becoming a true statement. Again, 27 equals 27. So we have another identity equation, just in disguise. So now that we're getting a feel for what an identity equation is, let's start adding some variables. 15 plus 6x equals 15 plus 6x. Even though it has variables in it, this is an identity equation. The left-hand side is identical to the right-hand side. This means that no matter what value we pick for x, we will always get a true statement. So let's pick a couple values for x and plug them in and see if that's true. Let's pick x equals 2. So we have 15 plus 6 times 2 equals 15 plus 6 times 2. Well, if we simplify both sides, we get 27 equals 27. A true statement. And the first identity equation we looked at. So let's pick another value for x. X equals 3. When we plug it in, we have 15 plus 6 times 3 equals 15 plus 6 times 3. When we simplify, we get 33 equals 33. A true statement. These are different numbers than what we got when we used x equals 2, but it still makes a true statement. So we still have an identity equation. Now this will work for any value we pick for x.
So it doesn't matter what you're picking, it's always going to work.
Now these do get harder as well. What if we have something like 3 times 5 plus 2x equals 15 plus 6x? The left-hand side doesn't look exactly like the right-hand side. But if we were to distribute in this 3, we end up getting 15 plus 6x equals 15 plus 6x. The identity equation we just looked at. Now let's do one more, a hard one. 15 plus 6x equals 1/2 times 32 plus 12x minus 1. Believe it or not, this is an identity equation. Now the left-hand side doesn't look anything like the right-hand side. But if we simplify that right-hand side, we find that we end up getting this original identity equation.
Look how ugly.
So this is just a really complicated identity equation in disguise.
And some of yours will look ugly like that, but they come out where the number equals the same. This is what we want to write down.
Is an equation that is true no matter what value we pick for the variable. Now, as you can see from the examples that were given, it's easy to be fooled when both sides of the equation don't look identical. So always watch out for identity equations in disguise. They tend to look like harder problems than they actually are.
So when we look at that, if we are looking at from this last video, whenever you get a true statement this time. So this time as we look at ours and we go, oh, we got this true statement, okay? Anytime we have a true statement, it means that we have an identity. That is not what we write for our answer. We don't write, oh, identity equation. Our answer is for x, all real numbers, okay? So as we do our problems that we're going to take a look at, you're going to see all real number solutions. That means if I was looking back up here, and I just finished solving this one, and 6 equals 6, and I know this is a true statement, that means that x is going to be equal to all real numbers. That means if someone wants to say, you know what, the answer to this problem is 4, 4 works. Someone else picks -3, it works. Someone else picks 1/5, it works. Okay? It doesn't matter what you pick because the two sides were going to equal out. So what we want to take a look at is we want to try and solve these. So we're going to do a couple of these, and then I'm going to let you do a couple of the last couple ones. Because in your homework, you're going to see ones like this. So the first thing we want to do is distribute here. So if we are writing that, that's going to be 6x minus 6 plus 4. On the other side, when you distribute the 2, you're going to have 2 times 3x, which gives us 6x, minus 2 times 1 is 2. When we add our like terms here, we end up with 6x minus 2. Or you could put plus a -2 equals 6x minus 2. Now we might already be realizing it's exactly the same on both sides. So Zach, if I wanted to get rid of the x, what would I do? I'd minus 6x. And when I subtract 6x, I get the same number equal. -2 equals -2. Be really careful that you keep that negative with it, because if you said 2 equals -2, it would be no solution. But in this case, this is a true statement. So my value of x is going to be all real numbers. If I am solving that second equation, I want to add my like terms together on this side first. So I write 4x minus 12. Once I do that, Ellie, and I add my like terms, 6x minus 2x is gonna give us
4x.
4x. And if I am adding negative 4 plus 8,
You get 4.
I'm gonna have 4. So now Wyatt, next step. Make sure you're writing down where we're at. What are you gonna do?
We have to subtract 4 from both sides.
Not 4, we wanna get our variables. Get rid of the variable first. So subtract
4x.
4x. If I subtract 4, that's usually in the number. So I want to subtract 4x on both sides. And when I do that, I'm left with negative 12, because that's a 0, equals 4. And that is a false statement. And since it's a false statement, I say x is equal to no solution. There is no number you can choose that will make it true. Okay? In this next equation, Ava, we want to add our like terms. What am I going to get on that first side of the equation when I add my like terms? 5x. I have 5x plus 2. Equals, on the other side of the equal sign, Avery, when I add my like terms, I'm going to have what? 8 plus 3x. I now, as you are writing with us, Braden, you writing with us? We want to get rid of one of the x terms. What's my smallest x that I want to subtract? 3x. So we're going to subtract 3x. Are the x's canceling in this one?
No.
No. This is like what we've been doing earlier. So I get 2x plus 2 is equal to 8. Layla, next step?
Subtract 2.
Subtract 2. I get 2x equals 6. Brian, what am I going to do next? Divide them both by 2. And x is equal to 3. And I get a solution. And when I've had students do at this point, they'll go back and tell me, all real numbers are no solution. No, this is the one answer. It's only one answer. There's not every number that works, only 3 works. That's the only one that will make it true when I substitute it back in. So it's like the problems we've been solving. Now, just by looking at this one, subtract your 4x from both sides and tell me your answer. Subtract your 4x from both sides and tell me your solution. Do that on your paper. You can check with your shoulder partner. Subtract 4x from both sides and then tell me. Is it did we get one answer? Is there one solution? Infinitely many or no? It should be. And in this case, instead of writing infinitely many, we usually write all real numbers. So infinitely many or all reals I would take. Okay? Your assignment is D8. So our quiz is moved until later this week. On this worksheet, you are not going to do all of the questions. And I put it up on the daily planner, and I will tell you specifically which ones you're going to do. And then I will pass the scissors out so you guys can cut out your homework for me. So at the top, you are going to do number 1. You're going to do, let's change the color here. So you're going to do number 1. You're going to do number 3, 5. You're going to do 6 to 9. So there was originally 18. We're cutting it back to 12 problems. 12, 13, 15, 17, and 18. And the reason I chose some of these, and some of them are going to have an answer, but they're going to get one answer, like the first couple ones. You can check the answers in the back. But when you get to a question like number 6, if we were going to start number 6 together, in number 6, if I'm adding my like terms on this side, Lizzie, and I have negative 8x minus, or negative 8t minus 3t. What am I going to get when I add those like terms? Negative 8 minus 3. And I could even change this to plus and negative, right? I could change my subtraction. What am I going to end up as I get those two? I'm gonna have negative 11t plus 2. And on the other side, I'm gonna add my like terms in number 6. And I have negative 5t plus negative 6. And if I add those two together, I am gonna have an answer thing of what?
Negative 11t.
Negative 11t. So I start looking at the problem and I'm thinking, what should I do to get all the variables on both sides? Connor, I should do what? And- Not subtract it because that'd give me a negative 22, but add 11t to both sides. So I add 11t. And I end up with 2 equals 0. And that is a false statement. And because it's a false statement, I now say t is equal to no solution. Okay? If it would have came out that 2 equaled 2 in a true statement, then I put all real number solutions. Okay? So the first ones, actually, you do get a number answer, just like we did in this one here. You will get a number answer, and that's okay as you're looking